So rates of changes is very much similar to small changes or approximate changes. But the thing is that if one variable changes with respect to time, it will cause the other variable to change with respect to time as well. In small changes, when one variable changed, it caused the other variable to change. But in this case, we are considering time. If one variable changes with respect to time, it will inevitably cause the other variable to change with respect to time. Then, such a question falls under the category of rates of changes. And in order to solve such questions, we form, or rather use, the chain rule. There's no rectification with respect to the chain rule, and we learn how to form it. We'll get into that in just a bit. So, this is the first example. The radius of a circle is increasing at a rate of half centimeter per second. So, since it is centimeter per second, it's with respect to time. That's what we know. So, we can write this information down as, let's say, dr over dt, that is rate of change of radius, is equal to half centimeter per second. And we need to find the rate of change of area, which is dA over dt at the instant when the radius is 3.5. So first of all, form the chain rule. We have the rate of change of radius. We need to find the rate of change of area. So this is what we need to find. And so first of all, write this down as dA over something into something over dt. So these two things will cancel out and we'll end up with rate of change of area. So what's the third variable? Ask yourself. It's radius. So when dr cancels out, we'll turn out to have dA over dt, and this is our chain rule. So the first step's gonna be finding dA over dr. We know that the formula for area of circle is pi r square. We'll differentiate this with respect to r, that is area differentiated with respect to r, dA over dr is 2 pi r. And then the second step's substituting the original value of r. That is, in this case, we are given that we need to find the rate of change of area at the instant when r is 3.5 centimeter. So dA over dr is what we found here. Substitute r as 3.5, and this is what you will turn up to have. I'll use pi as 22 over 7, and I end up having something like this. That is 22 centimeter square. So this is my rate of change of area. No, rate of dA over dr. And then I need to find the rate of change of area. I'll do that using the chain rule I formed. So first of all, dA over dr is 22. I'll substitute that. Then dr over dt, that is rate of change of radius, is half centimeter per second, and thus we'll end up having 11 centimeter square per second. That's the rate of change of area. Alright, this is gonna be centimeters, my bad, since This was area and this is dA over dr. Just satisfy the units, mind you. Moving on, example 2. Find the rate of change of area and volume of a sphere at the instant when radius is 7 centimeters and rate of change of radius is this. So we have dr over dt. We have to find rate of change of area and volume when radius is 7 centimeters. First of all, how about we make a margin and consider surface area. The area of a sphere is obviously the surface area of the sphere, which is 4 pi r square. And then in the second column, we'll use that for volume of sphere, which is given by 4/3 pi r cubed. In the first column, we'll work for rate of change of area. We'll form the chain rule as this. So we have dA over something and something over dt. The third variable is the radius. So we write that down. This is our chain rule form. Then differentiate the formula of area, alright, with respect to r, and we'll end up having 8 pi r. Since we need to find rate of change of area at the instant when r is 7, we have 8 pi into 7 is equals to 176 when pi is 22 over 7, mind you. And then simply use this chain rule. Alright, so we'll substitute the values. So 176 into rate of change of radius, which was given as 1 over 4, and we end up having 44 centimeter square per second. The units marks are only for the final answer, I guess. So need not worry about this. Just remember that rate of change of area, so it's gonna be centimeter square over seconds, or according to the question, whatever units are being. Then work for the rate of change of volume. So first of all, form the chain rule. So I have dV over dr, since I know radius is the third variable which will be used to relate, and then find dV over dr. So differentiate this and you will end up having 4 pi r square. Pi is 22 over 7 and r is given as 7 centimeter. Thus, this is our dV over dr. Then use the chain rule simply. Using the chain rule, we have dV over dt is equals to, substitute the value 616 into 1/4, that is rate of change of radius, and we end up having 154. Volume is in centimeter cubes and it's per unit time, so it's s minus 1. And these two are our answers. And finally, my favorite part, that is the last example. This time we have a cuboid ice block which has one side of x centimeters and it is melting at a rate of 2 centimeter cube s minus 1. So this is dV over dt. Find the rate of change of side x and area at the instant side is when the side is 5 centimeters. Alright, we need to find the rate of change of side x. So we have three variables dv, dt and x. Alright, so dx. So first of all, look into the chain rule. Dv over dt, which is given, is equals to something like this. Since we do know that x is the third variable, and that will be used to form the relationship. What do we need to find? We need to find rate of change of side x in the, yeah. So first of all, dv over dx, area of, we do know that the volume of a cuboid is given by x cube. Thus dv over dx is 3x square. The original value of x is 5 centimeters. So 3 into 5 square is equals to 75. Moving on. So I guess we do have the information we need. We'll substitute the rate of change of volume. Then dv over dx is 75. And this is what we need to find. Rearranging the equation, we have dx over dt is equals to 2 into 1 over 75, or just 2 over 75. But mind you that dv over dt is not 2 centimeter cube per second. In fact, this is the most important part, that you need to realize that the cube is melting, and thus it's minus 2 centimeter cube as minus 1 when written as a in mathematical terms. So it's minus 2. You must not forget this, and the value of the size is decreasing. Thus, this is our final answer, and yep, minus is important in this case. Why? Since it's melting. So this is, but this is not the end of the question, since we are also asked to find the rate of change of the area after finding the rate of change of side x. Once we have the rate of change of side x, we can proceed to find the rate of change of area. First of all, since this is what we have to find, form the chain rule. So we have the third variable used to relate dA over dt, dA and dt. Thus, this is our chain rule. We have this thing right here, and we need to find dA over dx. When it comes to 3D shapes, remember that when talking about area, we're talking about surface area, in this case of a cuboid, and that is given by 6x square. X square is the area of one face, and we have 6 faces. Thus, differentiating this would give me dA over dx, which is 12x. Using the original value of x, that is 5, or at that instant the value of x is 5. This is my value of dA over dx. Once I have this, I can proceed and use the chain rule. So I have dA over dt. dA over dx is 60, and rate of change of side x was what I found out as minus 70, minus 2 over 75. Thus, the minus is very important. Without that, your answer would be wrong. Since this is area, you also need to be vigilant about the units. and this is my answer. This and this would be left as my answer. And this is where we wrap up rates of change.